In this video, I will show you how to find the vertical asymptotes and wholes of rational functions. This is AP Precalculus, topics 1.9 and 1.10. If you appreciate this content, please show it by hitting that like button. For each of the following rational functions, determine and label any values of x where the graph has a hole or a vertical asymptote. Vertical asymptotes and wholes both stem from the denominator, but we get a hole when the denominator factor cancels out, and we get a vertical asymptote when a denominator factor remains. For example, I see x minus 5 in the denominator, but that is going to cancel out with this factor in the numerator. Because it cancels out, this is going to give us a hole. We have a hole at x equals 5. Then we see a factor of x plus 2 in the denominator that does not cancel out with anything. A denominator factor that remains gives us a vertical asymptote. So we have a vertical asymptote at x equals negative 2. Number 2, focus on the denominator. This factor of x minus 3 does not cancel out with anything. So this will give us a vertical asymptote. A vertical asymptote at x equals 3. We have a factor of x plus 1 in the denominator. This doesn't cancel out with anything either. So we have a vertical asymptote at x equals negative 1. In number 3, we see two factors of x minus 6 in the denominator. Even though one of the factors cancels out with the x minus 6 in the numerator, this will not give us a hole. Because one factor of x minus 6 remains in the denominator, this will give us a vertical asymptote. We have a vertical asymptote at x equals 6. Number 4, the x plus 2 squared in the numerator means that we have two factors of x plus 2. I think I will write it separately just for clarity. So we have x plus 2 times x plus 2. Now focus on the denominator. We have this one factor of x in the denominator that does not cancel out with anything. So because it remains, this will give us a vertical asymptote. A vertical asymptote at x equals 0. The x minus 1 factor in the denominator does not cancel out with anything. So that's going to give us a vertical asymptote as well. A vertical asymptote at x equals 1. What about the x plus 2? The x plus 2 in the denominator cancels out with one of the x plus 2's in the numerator. No x plus 2 remains. So this does give us a hole at x equals negative 2. It doesn't matter that a factor of x plus 2 remains in the numerator. Because the denominator factor cancels out, we still have a hole. In number 5, r of x needs to be factored first so we can see what is going on. This trinomial in the numerator will factor as a binomial times a binomial. X squared is going to be x times x. 6 is going to either be 2 times 3 or 1 times 6. Inner plus outer must equal middle. To get a middle of positive 1, we need a negative 2x inner and a positive 3x outer. Notice that the denominator has a common factor of x. If I factor that out, I will have x times x squared minus 4. But this is the difference of two squares. So we can factor that further as x times x minus 2, let me line them up, times x plus 2. Now focus on the denominator. The factor of x does not cancel out with anything. So that's going to give us a vertical asymptote. So we have a vertical asymptote at x equals 0. The factor of x minus 2 cancels out with a factor in the numerator. So that's going to give us a hole. So we have a hole at x equals 2. The x plus 2 in the denominator does not cancel out. So that's another vertical asymptote. So we have a vertical asymptote at x equals negative 2. Number 6, p of x will require some factoring as well. In the numerator, we have the difference of two squares, so this is going to factor as x plus 1 times x minus 1. Now be careful, some students think that x squared plus 1 will factor as well. It will not. X squared plus 1, the sum of two squares, is never factorable. P of x will have no vertical asymptote or whole. The x squared plus 1 is the only factor in the denominator. Obviously, it doesn't cancel out with anything. X squared plus 1 will never equal 0. X squared will always be 0 or positive. So the smallest this can be is 0. Then you add 1 to it, and you have a positive number. So, because the denominator will never equal 0, you will never have a vertical asymptote. Or you can think of it this way. If you try to set x squared plus 1 equal to 0 and solve, you get x squared equals negative 1, and then x equals plus or minus the square root of negative 1, which is I. Imaginary numbers do not give you vertical asymptotes. For each of the following, write the left and right limit statements for f of x as x approaches 3. We are being asked to find the limit as x approaches 3 from the left of f of x and the limit as x approaches 3 from the right of f of x. Quick side lesson. If we have a vertical asymptote at x equals 3, then the limit as x approaches 3 of f of x will be either positive infinity or negative infinity. That's because approaching an asymptote from the left or the right is either going to do this, meaning approaching positive infinity, or it's going to do something like this and approach negative infinity. These are the only options. On the other hand, if we have a whole at x equals 3, the limit as x approaches 3 of f of x will be a constant, and that constant is the y value of the whole. Approaching a whole from the left works like this. You're approaching a specific number, not infinity. Approaching from the right looks like this. All right, we are approaching the y value of this whole. In this case, the x minus 3 in the denominator does not cancel out with anything. That means we have a vertical asymptote at x equals 3. So the limit as x approaches 3 is going to be either positive infinity or negative infinity. We can figure out whether it's positive infinity or negative infinity on the left or the right by making a partial sign chart like this. We just need to figure out whether these factors are positive or negative near 3. So to figure out whether x plus 2 is positive or negative near 3, we can just plug in 3. If we plug in 3, we get 5. That's a positive number. So x plus 2 is going to be positive very close to 3 on the left and the right. We can do the same thing with the x minus 6. If I plug in 3, that's 3 minus 6, that's negative. So x minus 6 will be negative near 3 on the left and the right. We can't just plug in 3 here because that's just going to give us 0. So for this one we have to actually think. If we pick a number to the left of 3, like let's say 2. 2 minus 3, that's going to be a negative number. So this factor will be negative to the left and positive to the right. The overall sign of f of x near 3 but to the left is going to be positive because we have an even number of negatives on the sign chart. Near 3 but to the right, f of x will be negative. So that means we have positive infinity as x approaches 3 from the left and negative infinity as x approaches 3 from the right. So this is the answer to number 7. For number 8, we begin by deciding whether we have a vertical asymptote or a whole at x equals 3. We see that the factor of x minus 3 in the denominator cancels out with the factor in the numerator. That means we have a whole at x equals 3. We learned in the side lesson that if we have a hole at x equals 3, then the limit as x approaches 3 from the left or the right will equal a constant, and that will be the y value of the hole. To find the y value of the hole, consider the related equation y equals x plus 3 over x. This is the equation that you get after you cancel out the x minus 3. This will give us the y value of the hole if we plug in the x value of 3. So y is equal to 3 plus 3 over 3. In other words, y is equal to 6 over 3, which is 2. So the limit as x approaches 3 from the left of f of x and the limit as x approaches 3 from the right of f of x both equal 2. By the way, notice I use an equal sign for these limits when it's a constant, but I use the word is when it's infinity. Infinity is not a number, so it's not really appropriate to say that a limit equals infinity. So use the word is. For number 9, the x minus 3 in the denominator does not cancel out, so we know there will be a vertical asymptote at x equals 3. That means that the limit as x approaches 3 from the left or the right of f of x will be either positive infinity or negative infinity. To figure out where it's positive infinity or negative infinity, we can make a small sign chart showing the signs of f of x near 3. So between 2 and 4, say. Negative 2 is always negative, so this will be negative here and here. When you square something, it's always going to be positive or 0. So this is going to be plus and plus. That means the overall signs of f of x will be negative from the left and from the right. So the limit as x approaches 3 from the left of f of x and the limit as x approaches 3 from the right of f of x is negative infinity. Write an equation of a rational function that has the following properties. Number 10, the graph of f has a hole at x equals 3 and a vertical asymptote at x equals 1 and x equals negative 4. Since f of x has a hole at x equals 3, that means we need a factor that cancels out. So x minus 3 in the numerator and the denominator. We have a vertical asymptote at x equals 1, so we need a factor in the denominator that does not cancel out, so x minus 1. And we have a vertical asymptote at x equals negative 4, so we need an x plus 4 in the denominator that does not cancel out. This is the final answer. In the previous video, we put a c right here for a constant, and we had to solve for it. But that was when we were told the y value of the hole, and we had to put this constant here to make the y value come out to be what we were told that it is. But for this problem, for all of these problems, we are not given the y value of any holes. So this is all we need. Number 11, the graph of g has a hole at x equals negative 1, a vertical asymptote at x equals 7, and a 0 at x equals negative 2. The hole at x equals negative 1 means we need a factor of x plus 1 that cancels out, so numerator and denominator. The vertical asymptote at x equals 7 means a factor of x minus 7 in the denominator that does not cancel out with anything. The zeros of a rational function come from factors in the numerator that don't get canceled out. So we need an x plus 2 in the numerator that cancels out with nothing. Number 12, the graph of h has a hole at x equals 2 and x equals 5, a vertical asymptote at x equals 0, and a 0 at x equals 1. A hole at x equals 2 means a factor of x minus 2 that cancels out. Same with a hole at x equals 5, which gives us a factor of x minus 5 that cancels out. A vertical asymptote at x equals 0 means a factor of x in the denominator that does not cancel out. And a 0 at x equals 1 means a factor of x minus 1 in the numerator that does not cancel out. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.